Good morning, students. Today we are going to study about the topic light, chapter 16, page number 199. Okay, have you all know about light? In the daytime, we can see all the object around us, right? At night also, we see the moon and stars. But if you are sitting in a dark room, is there any object visible to our eyes? No. We need light for seeing these object. Okay, so light is a form of energy. It helps in the sense of vision. When light falls into an object, some of the light is reflected back to our eyes also. Okay, it helps in the sense of vision. Vision means we are seeing an object. Okay, if the light falls on an object, some of the light is reflected back to our eyes also. Thus, we are able to see an object because of light being reflected from the object. Okay. While the light falls on an object, we are able to see the object easily. Okay, then the next topic is what makes things visible. Okay, when light falls on a shining surface, most of it bounces back to the eyes, right? It is called what? Reflection of light. So it makes light to see the object easily. Okay, when light falls on a shining surface, what happens? The light reflect, bounce back. The bounce back of the reflection is called what? Reflection of light. Then the other topic is laws of reflection. Okay, here there is an activity 16.1. First I explain the activity, then I have given one example video also for that activity. Okay, first we want to fix a white sheet of paper on a drawing board or a table. Then take a comb and close all its opening. Then hold the comb perpendicular to the sheet of the paper. Throw light from a torch through the opening of the comb from one side. What happened? With slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and the torch steady. Then place a strip of plain mirror in a path of the light ray. Okay, what will you observe? After sticking the mirror, the ray of the light is reflected in another direction. Okay, while we are sticking the mirror, the ray of the light is reflected into another direction. The light ray which strikes any surface is called what? Instant ray. Okay, after sticking the mirror, what happened? The ray of light is reflected into another direction of the light ray. So, the strikes any surface is called what? Instant ray. Then, the ray that comes back from the surface after reflection is called what? Reflector ray. Okay. When we are striking the mirror, we are using torch for light, right? That is called what? Instant ray. Then the ray is reflected back to us, right? From the surface. That reflection is called what? Reflector ray. Okay, ma? Okay, then watch the example video. Okay. draw a normal and also angle of reflection line. Okay, for that we want to take what? Draw line showing the position of the plane mirror. Then the incident ray and the reflected ray on the paper with the help of draw with the paper with the help of your neighbors or friends. Then remove the mirror and the comb. Then draw a line making an angle of 90 degree to the line reflecting the mirror at the point where the incident ray strikes the mirror. Okay, see the picture. They are drawing a 90 degree to the line representing the mirror at a point when the incident ray strikes the mirror. Okay, they are drawing 90 degree. Then this line is known as what? Normal line. Okay, straight we are drawing what? Normal line. It is next to the incident ray. Okay, then this line is known as what? Normal to the reflecting surface at a point. Okay, it is reflecting surface of the point to the incident ray. Okay, the angle between the, see the picture ma, the angle between the normal and the incident ray is called what? Angle of incidence. Okay, angle of incidence symbol represented as I. Okay, first we want to draw a normal line. Okay, the angle between the normal and the incident ray is called what? Angle of incidence. Okay, then the angle between the normal and the reflected ray is known as what? Angle of reflection. Okay, while seeing that activity, in that activity we want to draw what? Incident ray first. Okay, then we want to draw 90 degree normal line. Then we want to draw what? Reflected ray also. Okay, the angle between incident and normal is angle of incidence. Okay, it represented as I. Then the angle between the normal and the reflected ray is known as what? Angle of reflection. It is represented as what? R. Then measure the angle of incidence and the angle of reflection. Okay, the angle of incidence is always equal to the angle of reflection. So this is one of the law of reflection. Okay, the angle of incidence and is always equal to the angle of reflection. See the picture, the incident and the reflections are equal. So we call that as what? Laws of reflection. Okay, then the incident ray, the normal at the point of incidence and the reflected ray all lie in the same plane. Okay, the incident ray and the normal at the point of incidence and the reflected ray all lie in the same line. Okay, then activity 16.3. okay, a source of light O is placed in front of a plane mirror PQ. Okay, PQ is a plane mirror. See the picture ma, here they are representing PQ as a plane mirror. A source of light O is placed in front of a plane mirror. O is a source of light. Source of light means it may be torch or anything. Okay, two rays OA and OC are instant on it. Okay, OA and OC are instant on it. Then can you find out the direction of the reflected ray? Then we are going to draw what? Draw normals to the surfaces of the mirror PQ at a point A and C. Okay, they have marked red line, red dot, right? It is a normal surface of the mirror at a point A and C. Then draw the reflected ray at the point A and C. Then they have drawn a line. See the line ma? They have drawn two perpendicular parallel line, right? Draw normals to the surface of the mirror PQ at a point A and C. Then draw the reflected ray A and C. Okay, as a straight line. Then how would you draw these rays? Call the reflected ray AB and also CD. Okay, reflected ray AB and also CD. It is reflected. Okay. Then do they meet now? If they meet means what? Mark the point as I. If it is meet means what we do? We want to mark the point as I. For a viewers, I at E. Okay. Do the reflected appear to come from the point I, since the reflected ray do not actually meet at I. Okay. But only appear to do so. We are using what? I. First, we want to take what? Source of light, torch or anything, and place in front of the mirror PQ. Then two rays OA and OC are the instant on it. Okay, we are giving light, so it is instant to the from the mirror. So OA and OC are the instant ray. Then we want to draw what? Reflected ray. For that we are using what? We are marking A and C and draw a reflected ray. Then we find out the reflected ray AB and also CD. While we are observing with our eyes, it meets into one line. That line is called what? I. Okay. Then an image formed by a mirror left of an object appears on the right and the right appears on the left. This is known as what? Lateral inversion. Okay. An image formed by the mirror left of an object appears on the right. It is because of reflection, and the right appears on it is into left. This is known as what? Lateral inversion. Okay. Then the next topic is regular and diffused reflection. What is meant by regular and also diffused reflection? Here also one activity 16.4. Here we want to imagine what? Parallel rays or instant on a irregular surface. It is not a smooth surface. Okay, it is a irregular surface. See the picture, the surface is irregular. Okay, then we want to know the law of reflection or valid at each point of the surface. Here there are some laws of reflections each point of the surface. See the picture, there is having each point there is a reflection. So law to construct what? Reflected ray at various point. When all the parallel rays reflected from a rough or irregular surface are not parallel. See the picture, it is slanting, right? The reflection is known as what? Diffused or irregular reflection. The parallel rays and the reflected from the rough and irregular surface means what happened? It is not parallel. It is slanting. So it is called what? Diffused or irregular reflection. If it is a smooth surface means what happened? It is parallel. The reflection is also parallel. So it is called what? Regular reflection. In figure 16.8, it is a smooth surface. So it is parallel. So the mirror is called what? Regular reflection mirror. So images are formed by regular reflection. Okay, if it is rough and irregular surface means it is slanting. The reflection is slanting. It is not parallel. So it is diffused or irregular. If it is smooth surface means it is regular reflection. Okay. Can you all understand the difference, ma'am? Then Then reflected light can be reflected again. For that, here there is a best example. Okay. If you are going to a shop for cutting your hair, means what happened? You are seeing the image of your using mirror, right? After your haircut is complete, what will you do? He or she hold a mirror behind you to show what? Your hair. See the picture? They are showing what? Mirror to see your backside, right? Why they are using that mirror? It is a periscope, makes use of two plane mirrors. Okay. Here, the reflection from two mirrors enables you to see the object which are not visible directly. Okay. So only they are using what? Another mirror to see the backside of your head. Okay. It is a periscope. Then the next topic is multiple images. Okay, here also one experiment. I explain the experiment, then I also give what? Example video for you. Okay, first we want to take what? Two plane mirrors. Okay, set them at a right angles to each other with their edges. Then place a coin in between the mirrors. What happened? How many images of coins were seen in that mirror? The mirror using the adhesive tape at different angles, say what? 45 degree, then 60, 120, 180 degree, etc. Then place some object in between them. Sometimes it may be coin or candle. Okay. Then we want to observe how many candles are there showing in the mirror. Okay. How many number of images formed by the mirror placed at an angle to one another is used in a kaleidoscope to make what? Numerous beautiful patterns. Okay. First we want to keep one object. Then observe the object in the mirror. Okay. Then mark the point of the object. Okay. Then activity 16.6, how to make kaleidoscope. Okay, that also I have given one activity example video for you. Okay, see the video and do the kaleidoscope. Okay, thank you, ma. That's all about today's topic.
Two lines are at 90 degree, these two lines are at 60 degree, these two at 45, and the these two lines at 30 degree. Correct. So I'm going to arrange the mirrors at 90 degrees like this. Also, I'm going to put an A4 size of paper over here. Now I must ensure that both the mirrors are joined together properly. Okay, done. Right? Now, what are we actually doing in this experiment is, this is our object and I am choosing to keep the object over here. Right? Now, there are two positions in which you can keep the object. One is on the angle bisector of the mirror, that is called the symmetric arrangement of the object from both the mirrors. So you can do that. So here, if I keep an object on the angle bisector, that means from this mirror, this angle is 45 degree, and from this angle also, the angle is 45 degrees. So exactly on the angle bisector line, symmetrically, I am putting the object. Now, let me say one thing, that what is going to happen over here is, now since there are two mirrors, I am going to call this as mirror M1, this as mirror M2. Right. This is the first image of this candle in mirror M1, and this is the second image and this is also the first image of this candle in mirror M2. Now these two are called the primary images. Now this primary image will behave as the object for the image of this mirror, guys. See, this image is visible over there. The image of this mirror is visible over there, and we can also consider that we can extend this mirror behind. So this is our extended mirror behind. We can extend the mirror behind. So this image will behave as an object for that extended mirror, and its image will be formed on the other side. Let me show you that. So that is very well visible that now this image will behave as the object for that mirror, which is the extended. We can consider this mirror to be extended behind, or that is the image of this mirror in this mirror, or simply you can consider this as the extended mirror, and that is the secondary image of this primary image, because this is behaving as the object for that mirror, right? Now this secondary image cannot behave as the object, because you can see that this is the reflecting part of the mirror and this image is formed behind the mirror, so you have to stop there, correct? And the total number of images that you are seeing in this case is 3. Now guys, sometimes what happens is there are 4 images, but the last 2 images are falling on one another, like in this particular case. The image of this is here and the image of this is coinciding on that one, so we are considering that image as the one image. Actually there are 2 images, but they both are coinciding on one another. So hopefully guys, I have told you what is the theory part, and now let's start the experiment by keeping the angle between the mirrors as 120 degrees. So guys, now the setup is ready and the angle between both the mirrors is 120 degrees. This angle is 120 degrees, and this is the candle which is exactly at 60 degrees from both the mirrors. So it is on the symmetrical distance from both the mirrors. From here also 60 degrees, from here also 60 degrees. Now the formula says something like this. You can just see on the screen. So here from a distance we are able to see 2 images. Let me show you by bringing the camera more nearer. So guys, there are 2 images which are formed, and if I move around a bit, there is no third image which is seen. But if I displace this candle somewhere over here, and if I keep it at some asymmetric distance from both the mirrors, the number of images tend to change, guys. So this is the first image, that is the second image, and if you there you see there is a third image, guys. So total there are 3 images which are obtained when you keep this candle or the object at different distances. That means asymmetrical angles or distances, you will find 3 images.